Let's say you set up DHCP snooping in your environment. What is DHCP snooping going to do for you? DHCP snooping is designed to make sure that rogue DHCP servers are not able to hand out IP addresses to the clients within your network. So DHCP snooping is designed to protect you from DHCP spoofing attacks. That's what it's all about. So what are the things we need to keep in mind while we are troubleshooting DHCP snooping? Well, the big one is, did you enable it globally? It doesn't matter if you did all the other configurations. If you fail to enable it globally, then DHCP snooping will not be functioning correctly. So you can use the command show IP DHCP snooping to verify if it's enabled globally or not. And the command to enable it globally is IP DHCP snooping. When you analyze the output of show IP DHCP snooping, you can also verify if DHCP snooping is associated with the proper VLANs. You see, just because you enabled it globally doesn't mean it's going to be functioning for the individual VLANs. You have to make sure it's turned on a VLAN by VLAN basis as well. And the command to do that is IP DHCP snooping, and then you specify the VLAN. So if you set it up for the VLANs, but you fail to enable it globally, you have a problem. If you enable it globally, but you fail to set it up for the VLANs, then you have a problem as well. In addition to that, when you are setting up DHCP snooping, every single interface is classified as untrusted. And it's up to you to make sure that you trust the interfaces that are pointing to the DHCP servers. However, if you accidentally configure an interface as a trusted interface and that interface just happens to go to a rogue DHCP server, then that rogue DHCP server has the ability to now hand out IP addresses to the devices in your environment. So you have to be able to verify which interfaces have been set as trusted, and does that match your topology as you intend it to. So you can also do that with show IP DHCP snooping. Let's look at a sample output of IP DHCP snooping. We'll type in the command show IP DHCP snooping, and we can see from the output right at the very top that we enabled DHCP snooping globally. This is a must. You have to turn it on globally if you expect it to function for the individual VLANs. So once we enable it globally, we want to make sure that we are doing the snooping on a VLAN by VLAN basis. So here's where we can verify if we are performing the snooping on that particular VLAN. So in our case, off of ASW1, we want to snoop for VLAN 10, where we have PC1, PC2, and PC3. So it's important that we enable it for that VLAN. So to enable it globally, we would have typed in the IP DHCP snooping command, and then to enable it for the VLAN, we would then type in IP DHCP snooping VLAN 10 in order to make sure that we were snooping for that particular VLAN. So if you're troubleshooting issues related to DHCP snooping and it's not functioning as expected, meaning that users are getting IP addressing information from rogue DHCP servers, it might be one of these two reasons right here: that you forgot to enable it globally, or you forgot to enable it for that particular VLAN. If you enable it, then every single interface by default is going to be untrusted. Now, not every single interface is listed in this output. And the reason why is because everything is untrusted. So since everything is untrusted, meaning every port is untrusted for that particular VLAN now, what'll happen is that only changes you make to the default configuration will show those ports here. So for example, Fast Ethernet 0/2 is still an untrusted interface. So why is it showing up here? Because we added a rate limit command to it. We said, if you receive any an excessive amount of DHCP discover messages, right? We don't want that to happen. We want to limit that to 50 packets per second. Why? Because we don't want to have a denial of service attack launched against our DHCP server where somebody's trying to starve out our pool on our DHCP server by sending a whole bunch of DHCP discover messages to that particular DHCP server. So we can rate limit the DHCP discover messages that are coming in on this interface by setting that rate limit. So it's showing up here because we've modified a value. It's no longer using default values. We've changed it so that shows up here. In addition to that, we see gigabit 0/1 and 2 listed here simply because they are trusted interface. Why do we need trusted interface? Well, it's those interfaces that will transmit all types of DHCP messages. So our discover, our offer, our request, and our acknowledge messages. Untrusted interfaces only do DHCP discover and DHCP request messages. So these trusted interfaces are those interfaces where we will find our DHCP server upstream from them. So gigabit 0/1 and 2 on ASW1, you'll find a DHCP server upstream. And we see that in our topology. So those are trusted interfaces. If we fail to make these two trusted interfaces, then our clients are not going to be able to receive the DHCP messages, the offers, and the acknowledgments from the DHCP servers. So we need to verify these as well. So what are we looking for when we're troubleshooting DHCP snooping? 1, make sure it's enabled globally. 2, make sure it's enabled for the correct VLAN. 3, make sure you have the correct interfaces as trusted interfaces. If you accidentally add a interface, let's say fast Ethernet 0/2 as a trusted interface, and it just so happens there's a rogue DHCP server out there, then that might be the reason why clients are not receiving the appropriate IP addresses. Or you have some type of user that is now having traffic routed to them because they're giving out bogus default gateways. So keep these 3 items in mind when troubleshooting DHCP snooping.